Okay, so in this video, I'm going to introduce you what is Git and its relationship with GitHub and some relevant concepts one by one. So let's say now I have a program on my computer, which is on my disk, and I've installed Git on my computer to help me to control the version and store every change I have done. For this program, I'm going to use GitHub Desktop, this software. You could find it on internet, just search it. I will also post this website so you could download it. We got GitHub Desktop and our program here. So how to submit this program into Git, or say GitHub Desktop? Well, we need to first create a folder to let Git monitor it, right? Well, that is actually called a repository in Git. So we give this place a name, like I'll call it tutorial, and choose a local path to decide where you are going to put this monitor folder in. I'll choose here, and we'll talk about those things later. Now we could say there's a new folder and there's basically nothing inside. Ignore this two at first, and there's nothing in the history, and ignore this too. So now we could put our program inside the folder that is monitored by the GitHub Desktop, or say Git. Okay, we put it inside, and now GitHub Desktop, or say Git, I'll call it Git in the later video later. So it found there's a change, but it's not sure whether it should store it or discard it. And so you need to decide. If you don't want it, you just discard changes, and nothing, and it will delay this thing, delay every change that happened. And if we commit it, it will save this change. It will save it in the history, and you can see that there's a called create program.txt. Okay, now I add some change in my program. Change 1. Okay, I save it. And back to Git. It will find, oh, there's another change. Are you going to commit it? Yes, of course. So I committed it. It will set. In the history, you will see there's a change. Set update program, and here shows the change. What changed? And now I add change 2. Save it, and then Git will find, oh, there's another change. So before you commit it, you could give it title so that you know what is changed in this update. So let's call it change 2. Commit to main, and you could see in the history change 2, and here shows what changed. And now I add change 3. But I don't want this change. Actually. So I just discard changes. And open this, and open the program.txt again. We will find change 3 disappear. right? And it was not recorded in the history. So this is discard and commit the change. So what we did is now is to upload the program into the Git, and now we add a change. We add a change and Git record it down, and we add another change and Git also record it. So now I'm going to add some risky change, but I don't want my whole program crashed because of this change, right? So before I make this change, I make a new branch. Based on the program I have right now. New branch. I'll call it risk change. Risk change 1. Great. So now you see no difference inside this folder, right? But actually it has changed. It has totally changed. Let me explain what happened here is you create a new branch based on the master branch, or as it shows a main branch. Master branch equals to main branch. We create a new branch called risk change 1, right? And the Git will, because your risk change branch is based on the master branch or say main branch, it will copy everything in the master branch into the risk branch. That's why everything in the folder looks exactly the same, nothing changed. So now you can mess up risk change 1 while the master branch remains good. So now I'll add some risk change. Save it. And now it will find the Git will find there's a change, and I could save this kind of change. And now we could see the difference between risk change 1 branch and the main branch. If we are in the recent branches, or if we are in the risk change 1 branch, and we open this txt, we'll see risk change. And if we are in main branch and we open it again, there's no risk change. It's the original version. So this is the branch and the main branch. Basically, we keep main branch. Basically, we test our new functions and new changes in a new branch, not in the main branch or the master branch, so that main branch could keep running. So what we just do is Git copy the risk change 1 branch into our disk. Wait a second. Copy this branch into our disk, and we add a risk change, and Git stored it inside the risk change 1 branch, not in master branch or say main branch. So when we change back to master branch, the Git will delay what we have on disk and put syncing master branch back to the disk. So that's why we see the risk change line is deleted from the tutorial program txt. So it's the same thing when we change back to risk change one branch. It will copy those things back to our disk so that we could see what's inside the risk change and the risk change with write. So now we know what is Git. We know what is Git and what does branches mean, and what we know what is commit or say change means inside the Git. That means the history we made. This history we made, and we know how to create a repository in our local hardware disk. And master branch. So now we have a basic concept about master branch, which means master branch, or say main branch, is kind of like a base. It's the base of our program. Each time we want to make some change, we're based on the main branch, or say master branch. And each time we publish the master branch or main branch. It's like a reference and base, and so it's the most important branch in Git or GitHub and in our program. We will try our best to not mess it up. We could mess up the risk change one branch or change two branch or any other branch, but we must remain the master branch safe. So now we know what is master branch. And now we're going to talk about something about GitHub and the rest of concept. So until so far, we're talking about working alone. All the work is on my own computer, and so GitHub comes out when we need to co-op with others, where we want to publish our program into the internet. So GitHub will upload. We could use GitHub. We could use Git or say GitHub desktop to submit all those branches and its changes up to GitHub, so that if there's another user, let's say on the right side there's another collaborator or someone else, they have the right to access to your repository on GitHub. They could pull all your branches, which means it's copy and paste to his Git, right? And he could make some changes on, and he could choose one of the branch to make some new changes, to make some publish our repository. It's on the right side of the branches, so we publish it. Description, name. Keep this code private? No, because we're going to publish it and co-op, so don't keep this code private. Publish repository. Just a second. Recent branch. Oh, publish the other branches. Okay, so now we could go to GitHub, refresh it, and now we could see tutorial. This is repository. And now let's say someone make a change in the risk change 1 branch. I add here we could edit this file called corporation. So someone adds something, and we could commit this change directly. We'll talk about the pull request later, but we know that create a new branch means that based on the risk change 1 branch, we knew a branch. We knew a branch based on risk change 1 branch, and then merge them together later. That's what this option means, and we will talk about it later. Submit change. Okay, now it's changed in GitHub. So like so here's another change in the GitHub. So let's check in the GitHub desktop. So refresh. Yeah. Remember to switch to the branch we want to operate with. Okay, and now open the program again, program.txt again. Remember to keep the branch in keep in the correct branch. So now we could say cooperation, right? Because we pulled the whole branch from GitHub back to our local Git, or say GitHub desktop. So it gave pull corp back, and Git will copy this part of things back to our disk, so we could operate with it. So now we know how to upload our change to GitHub, and how to upload our change to GitHub, and how to download the change from GitHub. Okay, so here comes a little problem. Let's try this out. Someone makes a change in risk change 1 branch. Corp 2, and we also make some change in our local files, like local Git. Let's see, we add another change, and so when we submit the branch, this risk change 1 branch, you see there's a conflict, and what will happen? Let's check it out. So first, let's assume someone make a change change the file in GitHub. Version 2. Commit changes directly. Okay, so now files in the GitHub is changed. And in the GitHub desktop, which is local Git, we'll also make some change 3, and we save it, and GitHub find there is a change and commit it to Git, so that our change from our local disk will record to local Git. and now the conflict is occurred when we push our code, push our branch from local to website. Let's see what will happen. Yeah. It's unable to push commit. Fetch this, and it will require you to download this new comments before pushing your new change. Fetch. Okay, now we fetch from the GitHub, and now it knows what's new from GitHub and what's new from your local branch, and then pull the origin. You will see that, and it will tell you there's one conflict file. You see the program txt, there's a conflict. And now open in Visual Studio Code. It will open the Visual Studio Code for you. There's one more thing, like we basically need three software. One is GitHub Desktop, one is Visual Studio Code. It's not Visual Studio, it's Visual Studio Code. You can also find it on the internet. I'll post the website also. Visual Studio is for us to operate with C++ program, the whole program, and Visual Studio Code is used by GitHub Desktop to solve those conflicts. It needs something to open the conflict file, so it chooses Visual Studio Code. It doesn't support Visual Studio. That's a little bit weird thing, but anyway, let's open it. Let's open the conflict file inside the Visual Studio Code, and it will show you what is conflicted. You see now, here's our local change 3, and here's the remote the one we download from the GitHub, that is cooperation 2, and now you need to decide which one you're going to keep. To keep the one you download, or the one you write, or keep both. I'll choose keep both. So now you choose it, save it, Ctrl+S, save it, and close it. And now the GitHub Desktop knows the conflicts was solved, and you could continue merge. And so if we check the program txt, we'll see this 2 change was saved, and the conflict was solved. And now we could push our code to GitHub. What happened just now is we download this corp2 down to our Git, and you see there's a conflict, and the GitHub Desktop or Git asks us to solve the conflict manually, and we solve it by adding both of them. So now it's added, and we could push it, or you say upload all those changes to GitHub. Change GitHub. We could check it on GitHub. Refresh. Program txt, yes, change 3 and cooperation 2. So you see, it's a little bit messy if all of us work in one branch. So now I'm going to introduce how we're going to work in GitHub and Git. So what I'm going to do is to delete the branch, delete unnecessary branch. We go branch, your branches, and delete. Okay. So now there's only main branch, or say master branch, default branch, whatever you call it. There's only one branch remain, and the thing inside is change 1, change 2. And back to GitHub desktop. Refresh, and then it will tell you need to publish this branch because we've already deleted this branch on GitHub. So it will remind you to publish, but we're not. We're just delete the branch. Delete. So now there's only main branch remains, and let's see. Let's check in tutorial. Let's check this txt. Yes, only change 1, change 2 remain, which is the same as the file we got on GitHub. So what we do is to change the delete the risk change 1 branch, and now Git, the one in the Git, and because we deleted, so Git will delete everything about risk change 1 branch, and copy those things, the things in master branch back to disk. And the same thing happens to others computer. Yeah. So whenever we want like, for example, I'm responsible to add a class, add a student class or something. So I made a new branch, student, and in the student branch, I do my work. I do everything like create student class. So I can do everything that I want and write code without disrupt others' code or delay others' code. I focus on my writing, and after my write is my job is done. And you see the Git found there's change student class, and commit this change to Git, or you see GitHub desktop. You see there's a change, and now we publish this branch to GitHub, because you see there's no any other branches here, so we publish this branch. Okay, now it's published. Refresh. Yes, student branch. So what we do is we new a branch based on master branch, and then we add something, student, and submit this commit to Git, or say GitHub desktop, and we publish this branch to GitHub. Okay, so that's what we did. That's what I did. Like, for example, if Moses is responsible for creating a teachers class, then he would basically do the same thing. Like he would create a new branch in his local Git, or say GitHub desktop, and add some new things. Teacher, yes, and submit this to local Git, and let local Git submit this branch called teacher to GitHub. Alright, let's do it. For example, create a new branch. Oh, alright. It will automatically choose main branch or say master branch, default branch, because it's a default branch. If you want to choose another branch, actually you could, but I don't recommend, because we have our yes, but I don't recommend you knew a new branch on others branch. But if this one is yours, and I add a student 1 or 2 or something, that is okay, because this branch belongs to me, so I could do anything with it. So do not disturb others' code. Okay. Create a branch based on main branch. Oh, give it name. Teacher. Create a branch. Remember, switch to teacher branch, and you see this file is based on the main branch file. There's no student things inside. So add teacher class and save it. Teacher class. Submit this commit to Git, and now Git got those change. Git got this teacher change from here to here, and now publish this branch to GitHub. It will submit this whole branch to GitHub. Right? Okay. Let's check. Yeah, teacher and student branch. But now we think so in each branch, I think this branch runs good, student branch runs good, teacher's branch runs good. So I'm going to add it, merge it with the main branch, right? Let's add this teachers first. How to merge those two branches? Usually we merge it on the GitHub, the website, by using pull request. Like pull request means request for merge two branch. We'll make a new pull request, compare merge student to main, right? Let's say here it will list the difference, like student class, and the main didn't have student class. So create a pool, and create a pool. Okay, so now everyone could see, so others could see here's a pull class, and they could help you to check your code if there's any problem, and if everything is good, then we could merge the pull request. Squash and merge. Confirm. And you could delay the student class branch or not. It depends on you. So I'm choosing not to delay it. So now in the main branch, the program txt is now the same with students branch. And so what happened is merge student branch into master branch. So it will copy and paste. So the master branch was the main branch, default branch. It's the same with student branch. But when we want to merge teacher branch, see there's a conflict again. So how to solve it? Let's do it and check. Let's do it and check it. So new pull request, or say new merge request. Teacher to main. And you see, and it will remind you that it can't automatically merge, but you could still do the request. So, and you will check this branch has conflict that must be solved. Okay, so let's say the instruction. In instruction it says, now for the teacher, now pull the original main, which means download the main from GitHub to your local Git. It means for Moses, or you could say another user, he need to download the master branch from GitHub to his local master Git. Download it. So switch to main, fetch, pull origin, or say download, and now it has the same main branch with the one on the GitHub. And let's see what GitHub suggests us to do next. To check out teacher, Git checkout, switch to the brand of. Okay, that means to switch to the teacher's brand, and then rebase the teacher branch, because teacher's branch is currently based on the previous master branch, or say main branch. Is the old one, the old version. So we need to renew its base. So we need to renew its base by using the rebase current branch function. Rebase and choose main, because we have already updated main. If we didn't update main, it will say there's no difference and you can rebase. Rebase it. Are you sure? Yes, begin. And it will tell you what is conflicted. And open in Visual Studio again, and choose which to keep. I'll keep both, because both of those classes are useful. Keep both and save. And Git no, it was solved. Continue to rebase, and the conflict was solved, which means now it is rebased by adding this into it is updated. It updated its base. Okay, now we could. Now this branch is ready to merge with the main branch on GitHub. So push it, or say upload it to GitHub. Upload this new branch, this updated branch to GitHub. Yes. And now you could see this pull request is allowed. You could squash and merge, confirm, and now we could check in the main program txt. So now we have both student class and teacher class in the main branch, which is the branch we are going to publish on the internet, or we're going to submit as our assignment. Not those individual branches. Okay. So now when we know how to work on GitHub and what is branch merge and pull request, which is basically the same thing. And rebase means to update your branch to the newest content, which is usually to solve some conflict. And conflict solve, the Git will tell you when conflicts occur and ask you to open Visual Studio Code to choose which to keep or keep both. So we got all of them, and let's go through the whole process again if you want. This is optional part. So so this time we're going to start from GitHub website. Your repositories, new repository new test, and choose public, add a new readme file. Now add a git ignore, not now, create a repository. Now it's created, actually. It's created, and you could get started by creating new file. I'm going to add a .git ignore file. Ignore. Let me explain the .git ignore file. .git ignore file means to, just as its name, ignore some files in your repository and not upload it, and not monitor it, so that you won't see any change. You won't see the change in the Git, and nor you will upload it to GitHub. Because we are writing C++ program, so I'm adding. So I'm going to ignore two folder, which is actually three. Okay, those three folders. Save. Create ignore commits. Okay, now it is successfully created, and now back to local Git. So what happened is, yes, delete all, delete them all. So now in the master branch we have main branch. I'll call it main branch. This. We have a file called git ignore. Git ignore. You will see why I add this. File clone. If you want to add the repository from GitHub, then clone repository. Refresh. Yeah. Now we could see git test cloning. Okay. Now back to the file. Yes, we could find what it is downloaded from GitHub. So what happened is Git download the thing from GitHub and it stored it to our disk. So we're going to start up a C++ program by using Visual Studio Code. Create a new project, empty project, and choose a place. Remember to choose this location in the folder that is monitored by Git, or say GitHub desktop. Let me find it. It's here. GitHub test. Yes. Test. Choose it. I'll call just project 1. Create. Yes. Add a new. Just call it. Include IO stream using namespace std int main. No. Yeah. Cout message from main branch. Okay, now the first one. Now our basic program is done. Save it and close it. Close it. And now you could see there's only 5 changes. Let's see what happens if we create a project without the .ignore file. Because we haven't submitted those changes to Git, so Git will. So when we new branch, no ignore. Leave this change on main. Switch to branch. Okay. No ignore. And delete git ignore, and then you will see there's a bunch of file it found there's a change, but most of them is unnecessary and useless. So we use git ignore file and use these 3 rules to ignore all those unnecessary files, just like what we did in the main branch. Now you see with the help of the .gitignore file, there's only a few important file change was monitored by Git. Restore and give it a name. Build. First build. Submit to main and upload those changes from Git to GitHub. Now we could see project 1 here. Project. Perfect. So what happened just now is we download it and we add it. So first in the main branch we add more things. We add a whole project, C++ project. I'll call useful part and useless part. And because there's a gitignore file, the GitHub will only monitor and copy the useful one. And when we push it or say upload it, it will upload only this useful part onto the GitHub. If there's no gitignore, just like what we did to no-ignore branch, the no-ignore branch, let's say we create a new no-ignore branch and oh no, we created when we didn't submit those useful code. So so when we switch to no-ignore branch, to copy and paste, and we delay the gitignore file, and then create a C++ program. And we got useful and useless things, and there's no gitignore file, so Git or say GitHub desktop will monitor all of those files, whether it's useful or not. And if we push it, but I didn't, it will upload to GitHub, and those useless files will be pretty annoying when we merge the branches. Every useless file will have a conflict, so you need to solve them one by one. That's really annoying and it consumes a lot of space, right? So we use gitignore to prevent this thing happen. And one more thing, like just as what I said, we need to protect the main branch, right? We need to protect the main branch. So what if someone just adds some harmful code? Just delete them. What if someone like download our code from GitHub, and then he adds some harmful code, or harmful code, and then upload it again back to GitHub, so that he destroyed our project. So to prevent this thing happen, we could protect our branches by in the setting branches, add branch protect rule, and add name we want to name of branch we want to protect, that is main. Require linear history, and do not allow bypassing above settings. so that it prevents merging commits from push to matching branches, which means you can't directly upload things from your local Git up to GitHub. No, it's not allowed. When you try it, it's not allowed. And there's another way to harm our project, is to add a new branch. Add a new branch with harmful code inside and upload it. This upload will be successful because we didn't add rules on it. And then he pulled the request to merge this code up to main branch. If he didn't use a pull request, he just directly merge it, then he will do harm to our project. So we must require everyone to pull a request before merging. Okay, so that no one just merge harmful code into our main branch without checking. And yeah, okay, great. So now there's a rule, and if we change to main function, main branch test, and we change the git ignore files, like someone just delete out the rules, and so that he thinks it will mess up our code, and submit to he could submit to the local Git, because local Git doesn't have the rules on GitHub. Just like when there he cleared the whole git ignore file and then submitted to his local Git. That's allowed because it doesn't have rules on it. But when he tried to submit, that is not allowed. Let's say push origin. When you push, now you see there's an arrow. You can't push it. And if we do something, new branch, undo commit, yes, undo it, and discard change, yes, and new branch named harmful branch. Create a branch. Oh, which means git ignore, which means we create a harmful branch, and then switch into harmful branch, and then he did something bad to git ignore file. Save it, and you see the local Git will allow everything, and he upload this to local Git, and he delayed everything in git ignore, and now he could successfully publish it to GitHub. He could successfully upload this to GitHub, and you could see refresh a harmful branch, and then branch. Harmful. He has to create a pull request. Yes, now it needs a review. It needs a review. It needs another one to check out the code in order to merge it. It's blocked. So no one could just directly merge it with the main branch to harm it. So this is way you protect your main branch. So now we introduce two more concepts: git ignore and main branch protection. Okay, this is so far I've learned about GitHub and Git.